So lesson 11 for today, we had talked about this in class last week. We're going to find the slope between 2 points, which should be a lot easier now that you've learned how to find the slope from a graph and the slope from a data table. It's really not, there's no more new skills really to add in. So remember, slope is the vertical change, so up and down, over the horizontal change, left and right, often referred to as the change in y. Remember, triangle is changing, so change in y over change in x. And we started talking about how to find the slope using rise over run. If you haven't gotten to it yet in class, we will next week. So first example is find the slope between the points -3, 6 and 2, 4. We're going to start by just using our data table method because that's what you're familiar with right now. So you put the 2 points that they're giving you into a data table, and just like we've been doing for the last, all last week, right? You're going to find the change in y. So from 6 to 4 is a drop of 2. So this is your change in y, and you're going to put that in the numerator of your ratio. The x values, so here are your x values, go from -3 to 2, which is an increase of 5. So you get a slope of -2/5. That's it. So what is the symbol for slope again? That's right, m. Okay, so let's do these, maybe 2 more examples using the data table method. So let's find, let's find the slope between these 2 points. So we're going to make our table and put in the point 3, 4, and -7, -6. Okay. So here's your y values. We're going to do change in y over the change in x to find the slope, right? So look at your y values, which are here. They go from a positive to a negative, so you know it decreases by how much? So what's the distance between 4 and -6 on your number line? -10. So -10 is your change in y, which goes in the numerator, -10. The x values go from 3 to -7. So from 3 to -7 is also a decrease. The distance on the number line between +3 and -7 is 10. So your change in x is right here. This is the number that you put in the denominator. So you get -10 over -10, which simplifies to 1, +1. Ooh. Okay. Let's try using the slope formula. I was going to continue on, but I feel like we did so much work with this in class, and you did so well. I don't believe you're going to continue watching after that example. I think you've got it, and if you don't, you know that I'll work with you one-on-one in class. But most of you, I'd say a good 95% of you, really had it down before you left class. So let's go to the new stuff, right? So sometimes it's a little bit more entertaining. So this is called the slope formula, and it's the same thing. You're just finding the difference in the y values. So difference is a word that means subtract. You're putting that on top, and you're comparing it to the difference in the y values. But we refer to the points, the coordinates in the points, as y1, y2, x1, and x2. So that's usually where it gets a little tricky. So what you're going to do, and this is super important, and I remember when I was like a teenager learning this, that this right here made such a big difference when it came to using the formula. And with any formula, labeling your numbers. We have 4 different numbers, okay? They each get a different tag or a different mark. So for right now, you know that each coordinate has an x and a y in it, okay? We're going to call this the first point. So I'm going to label this like this, saying that this is x from the first point, so x1, y1. That's a 1 right there. Okay. Then I'm going to think of this as the second point, right? So this would be your x from your second point, y from your second point. x2, y2. Now, you're going to use this formula. This is referred to as the slope formula. You're going to be using this in Algebra 1, and from what I know, you also use it in earth science, so unless something's changed. So what we're going to do is right in this position. So there's 4 numbers, like 1, 2, 3, 4. And I have 4 numbers up here. 1, 2, 3, 4. We need to plug them in these spots. Making sure you plug in the right number in the right spot. So the first number we're going to use is y2. So we're going to put that here. y2 was what? y2 is 4. So I'm going to put that here. Minus y1, which is 6. Pink. Okay? Now, in the denominator, we need to do x2 minus x1. So x from the second point is here. So I'm going to put that first. Then x from the first point is here. Noting our minus and negative. Remember we talked about that like the first day of lessons? Comes up all the time. So hopefully that made an impact. You also have your calculator, but you know. All right. So in the numerator, 4 minus 6 is your change in y. We're going to put that on the top, negative 2. And 2 minus negative 3. Subtracting a negative is the same as adding a positive. So this could really be like this. Ha! It's awesome, right? 2 plus 3, 5. So your slope is negative 2/5, and both methods should get you the same answer. Whoa, super hard to get this on the camera without this little leg in the way. Okay, so let's do this without the pre-filled in parentheses here. It does make it harder, okay? So first thing you're going to do is it says using the slope formula, find the slope between the points. So you have to know the slope formula, right? So it's m equals y2 minus y1 over x2 minus x1. And you know what? If you're learning, why not go ahead and just make those little parentheses? It's going to eliminate you accidentally dropping a negative sign. Okay. Let's label our points. This is x and y. This is x and y. This is x from the first point, y from the first point. X from the second point, y from the second point. Let's plug them in. So the first number on top has to be y2. y2 is negative 6. We're going to do y2 minus y1. Whoosh. So negative 6 minus 4. Negative 6. Oh, man. Okay. I'm having camera issues. Bear with me. So this is a negative 6. I'm doing it in pen so you can see it, and now I'm in a spot where that looks a little sloppy. But this is negative 6 minus, and what was y1 again? 4. So we use these up. Okay. In the bottom, you're going to subtract your x's. I like to do these arrows to make sure I keep things in the right order. So negative 7 minus 3. Negative 7 is x2 minus x1, which is 3. Boom. Now you just have to punch it in. Negative 6 minus 4 is negative 10. And negative 7 minus 3 is also negative 10. Good news, because that's what we got with the data table method. And so this simplifies to 1. Woohoo! It is really, really important that you learn how to use formulas for science classes and for upper level math classes. It is a huge, huge skill. So in and of itself, using a formula, there's a lot of value in this. Even though you might choose to use the data table method, understanding how to use a formula, big deal, okay? And you know I don't tell you it's a big deal unless it really is a big deal. It is, it's a big deal. So we're going to stop there because I'm at the 9-minute mark. And I would like you to try to do the exit ticket, but what would be fantastic is if you could do example 3. I'm making you dizzy. Woo! Okay. Example 3. If you circle that right now, so I know you watched this video. Example 3, could you try the slope formula? It's going to be weird. Remember, I've only done it twice with you, and I said give me 10 times to explain it before you start to say, oh, I don't get it. I've only done it twice. So just try to follow through step by step, doing exactly what I did, using the slope formula, and then try the data table method. That would be awesome in addition to the exit ticket. I will see you soon. Thanks for coming. Won't stop recording, folks.